All right, today we're starting outcome D3, which is nuclear physics. The first lesson in this outcome is lesson 4, so Introduction to Nuclear Physics. So just to recap, so far in Unit D, we've been studying how electrons behave as they orbit the nucleus. Or in other words, we've been studying the atom as a whole, so we've been doing atomic physics. That was D1 and D2. Now we're going to look at the nucleus itself in more detail. So that's why this is called nuclear physics. And just so you know, towards the end of Unit D, we're going to study the fundamental particles that make up atoms, and that's called particle physics, and that will be outcome D4 when we get to it. So we're going to begin by looking at some nuclear physics vocabulary. Much of this vocabulary you probably already know, but just so that we're all on the same page, we're going to go through it. So we know that protons are the positively charged particles that are found in the nucleus. Neutrons are neutral particles found in the nucleus. And because atoms are neutral overall, in an atom, the number of protons equals the number of electrons. Now, all atoms of a given element contain the same number of protons. So if we have a look at this periodic table that I've got down here, so we've got nitrogen and we have oxygen. This number in the top left, that's the number of protons. So nitrogen always has 7 protons, no matter what. And oxygen always has 8 protons, no matter what. Okay, that's actually what makes oxygen oxygen. The fact that it has 8 protons is its defining thing. And the fact that nitrogen has 7 protons is the defining thing for nitrogen. So what this is saying is if you change the number of protons, the element itself actually changes. So if I take nitrogen and I somehow add an extra proton to the nucleus of nitrogen, then it's not going to be nitrogen anymore. It's going to turn into oxygen, for example. So transmutation is the process of changing one element into another. So as I said on the last slide, the way that you would change one element into another is to change the number of protons in the nucleus of that element. All right, next, isotopes are atoms that have the same number of protons, but different numbers of neutrons. So let's consider a carbon nucleus here. In this carbon nucleus, we have 6 protons and 6 neutrons. The fact that it has 6 protons is what makes it carbon. But then notice here, 6 plus 6 equals 12. So because we get a total of 12 there, this is carbon 12. Now, if we have a different carbon nucleus, so we'll look at this one in the middle, this is still carbon, so it still has 6 protons. But now this nucleus contains 7 neutrons instead of only 6 neutrons. 6 plus 7 is 13, so this is carbon 13. So carbon 12 and carbon 13, they're both carbon, they're just different isotopes of carbon. And we could even have carbon 14, so notice 6 plus 8 makes 14, and so that's another isotope of carbon again. Okay, so as I mentioned earlier, this number right here that I'm circling in blue, that is the number of protons in the nucleus. That number is also called the atomic number, okay? So in Physics 30, when you need to know the atomic number for something, you look on the periodic table. And there is a periodic table posted up on D2L for you. The mass number is the total number of protons and neutrons in an atom. Now, the mass number actually does not come from the periodic table in Physics 30, and I'll explain why in a second. This is where it comes from. So if you need to know a mass number, you look in the question. So it will be given in the question as part of the isotope name. So for example, let's say you're doing a question involving carbon 13. Well then 13 is your mass number, okay? The periodic table that's posted on D2L does contain this number here that I'm putting a box around on it. We do not use that number for anything in Physics 30. The reason is
That number, so 12.01 for carbon, is the average mass of all of the isotopes that exist for carbon. So if we went out, we found every single piece of carbon that exists in the world, and we averaged the mass of all of that carbon together, we would get 12.01. Now in Physics 30, we don't want to use the average mass for anything. Instead, we want to use the mass of a specific isotope. So that's why you get it from the isotope name, not from the periodic table. So the word nucleon refers to the protons and neutrons in an atom's nucleus. So really, nucleon just means something that's found in the nucleus. So protons are in the nucleus, so are neutrons, so they're both considered types of nucleons. So for example, let's say we had a carbon nucleus again. This nucleus, let's say it has 6 protons, it has to because it's carbon, and 7 neutrons. Then because 6 plus 7 is 13, we would say that this nucleus contains 13 nucleons. And so number of nucleons is really the same thing as mass number. Now make sure that you don't mix up neutron with nucleon. They sound kind of similar, but they're not the same thing. All right, in this outcome, we're going to use something called nuclear notation. So the nucleus of an atom is represented using nuclear notation. So nuclear notation is this thing here. X is the element symbol. So for example, let's say you're doing a question involving carbon, then instead of putting X, you would put C. Or if you're doing a question with hydrogen, you wouldn't put X, you would put H, because H is the symbol for hydrogen. A is the mass number, and that is, as we discussed, going to come from the question, not from the periodic table. And remember, mass number is the number of protons plus the number of neutrons. And Z is the atomic number, and remember that that comes from the periodic table. Okay, now we can also use this to calculate the number of neutrons. So N is the number of neutrons, and you can find that by doing the mass number minus the atomic number. What I usually just remember is that to get the number of neutrons, I just have to do the bigger number minus the smaller one. So the goal for today is to solve the table that's in lesson 4 of your notes. So you just need to do that nuclear notation practice that's there. And we are going to do 1 or 2 together here just so we can see how it works. So in your booklet, question 1 of the nuclear notation practice says that we have carbon 14 as our isotope name. And then we want to fill in all the rest of the spots here. So for the nuclear notation, we're going to put the symbol C. And then for our number of protons, we're going to look that up on the periodic table. So let's just go back for a second here. So the number of protons goes here on the bottom. So when I look on the periodic table for carbon, I see that carbon has 6 protons. Okay, and then the number that goes above 6 is just the mass number, which is given in the isotope name, and it's 14. There we go. So the atomic number, that was 6. Again, that came from the periodic table. That's the number of protons. The atomic mass here is 14. That came from the isotope name. That's the number of protons plus the number of neutrons. And so to get the number of neutrons, I just have to do 14 minus 6. And when I do that, I get 8. So carbon 14 contains 8 neutrons. Okay, we'll also do the next question. So question 2, they don't tell us the isotope name or the nuclear notation, but they do tell us the number of protons, which is the atomic number, and they tell us the atomic mass, and then the number of neutrons is a question mark. So I'm going to try to fill in where I put the question marks. So I know that only one thing on the periodic table has an atomic number of 8, because every element has a unique atomic number. So when I look on the periodic table, I see that the thing that has 8 protons is oxygen. So this is going to be oxygen. Now, in Physics 30, we don't just write oxygen, okay? We always have to write the element dash a number. So what we do is we look at the mass. It has a mass of 16. So our answer for this one is going to be oxygen dash 16. Okay, now I can fill in the nuclear notation. So symbol for oxygen is O. Bigger number goes on top, so 16 goes on top. The atomic number goes on the bottom. So there's my nuclear notation. And then finally, for my number of neutrons, bigger minus smaller, so 16 minus 8, which is 8. Okay, so now you need to finish the rest of that chart on your own.